Recording. All right, so today we're going to talk about an advanced feature. The first kind of advanced feature that is usually taught with linked lists is a thing called a tail node. And the idea of a tail node is that you keep track of the first node in the list using the head node, which we already do. And we also keep track of the last node in the list called the tail node. And when we're done doing this, it doesn't take a whole lot of work, but you do have to modify a decent amount of code. Once we've done that, I'll show you a couple of really strong benefits you get from keeping track of the tail node. So just a sec. Okay, so resuming the recording. So let me describe it right quick. We have our traditional head pointer, but in addition to that, we have a tail pointer. And again, the term pointer and reference are interchangeable. C++ and C and other programming languages use the term pointer because that's what they are. They don't have references in exactly the same way. Their references are different than in Java. But in Java, a reference is a thing that it's a variable that knows where an object is, and our nodes are objects. So we have a tail and head references. And the idea is when the list is empty, both of these pointers or both of these references are null, indicating an empty list. And when you add the first node to this list, what will happen when we're done is that both the head and the tail will be looking at that node because that node is simultaneously the front and the rear of the list. As we add items to our list, we will update the head pointer reference just as we have always been doing. But we will also now add the burden of updating the tail. So if we happen to insert at position 1 in this situation, this is position 0. So if we were inserting at position 1, then what we would want to wind up with is this situation. Now, if we added something between these two, the head and the tail would stay the same. But if we add anything onto the rear of the list, we want to update the tail reference and continually do this as long as we're adding items onto the rear. So anyway, this helps our list keep track of both ends of the list, which allows us to implement very interesting data structures like stacks and queues, queues. Very, very quickly. So without further ado, let's get into the code of doing this. And so I'm going to share my screen. And here's what I have done. I have created a class called MyLinkedListWithTail. So this one has a tail reference in addition to the head reference. Now, in order to speed this up, I don't want to rewrite the whole linked list class. I only want to modify it. So I'm going to get my linked list class that I've done before with my node declaration and all of the methods that I've done in class already. And I want to go ahead and use that because it's already done. And then I'm going to add stuff to it. So in order to copy this, I just need to make sure that my constructor is named the same. So I'm going to select the name, right? And now I'm going to start modifying my list. Sorry, my thing flashed over here, and of course I immediately lost my chat. Okay, so now those are over there. Now, the first thing I'm going to do is I'm going to add a second node. Private node, and this is a node reference. Remember, it's not actually a node, and I'll call it tail. And now I'm going to start going through the methods that I have here, and I'm going to modify them to accommodate this tail reference whenever that is necessary. And we'll do a simple one first. The constructor needs to set tail equal to null. I actually prefer to write that like this, just because it saves a little bit of space. This is perfectly legal cascading of the assignment operator. So I make sure that I accommodate both the head and the tail reference. And now I've got to go through my inserts and removes and make sure that they're modified. Let's think about the size and the print list. Well, the fact that I have a tail reference doesn't change the fact that the last node in the list is pointing at null. So even though I might be pointing at that node with a tail reference, that doesn't mean that its next is going to be changed, so it's still going to be null. So my size and my print list methods are going to be unaffected because they're still going to work perfectly even with the tail reference. Now, the first points that I want to address are the simplest ones, and that's the insert at head and remove at head. At this point, we have to worry about when we insert at the head node. We want to make sure that our tail reference is updated when necessary. And the only time this is necessary is when the list is empty. If the list happens to be empty, then the tail reference will need to point at the new node, because the brand new node will be the only node in the list, and both the head and tail will need to point at it. This is what I'm going to do. Notice how I say node temp equals new node, right? And I say temp next equals head, and that points it around the thing. And then I say head equals temp. Well, none of that is going to change, but I'm going to add a tiny bit of code at the end and just say, if the tail also happens to be null, in this case, then I'm inserting into an empty list. So if this is true, I want tail to equal temp as well. I could also set tail equal to head because they're both looking at the same object at this point. But that completes the code for insert at head, and now I've got the very first node is inserted and my tail is updated, which is perfect. Now, remove at head has an interesting problem, and that is if I have taken the last node off, then my tail reference is what's called dangling. It's holding a reference, it's holding a node that I don't want anymore. So if I'm removing the last element, and head, which automatically sets itself to null in our remove at head, right here, when it does this, it will set itself to null if that node was the last node. Well, then what I want to do is make sure that that wasn't the last node. So if head is equal to null, then I just remove the very, very last node. And so I want to set tail equal to null, because now they're both pointing at nothing and everything is fine. So both my remove, both of my actions at the head of the list, insert at and remove at, are pretty trivially modified to keep this tail reference intact. The insert at